Hi, this is a small tutorial covering transient analysis and AC analysis in LT-Spice. Earlier, what we have seen is DC operating point analysis. It calculates the DC voltage at each node and current for each branch in the steady state of an electronic circuit. Now, coming to transient analysis, it is used to analyze the changes in current and voltage over time when an input signal is applied to an electronic circuit. Let's try to perform transient analysis for first order RC filter. For that, let me first create a new schematic and plug in resistors and capacitor and a voltage source from the component editor. Voltage source. Connect all of these through a wire. And place a ground. Let me select the values of the resistor and capacitor present in your manual. Let it be 1K. Sorry. Let it be 1 kilo. And the value of capacitance will be 0.1 microfarad. And if you see, this is a DC voltage source, and for performing transient analysis generally you will go with an AC voltage source. So just right click on that. Here it asks for DC value since it is considered as a DC voltage source. Now we have to change it to AC. So go to advanced, go to, let us take a sinusoidal source, go to sine and set the DC offset value to be 0. Let input peak to peak voltage be 2 volts and frequency be 1 kilohertz. See, this voltage source is now a sinusoidal source with peak to peak voltage 2, DC offset 0 and frequency 1 kilohertz. Now to perform transient analysis, just go to before that, let us label the input and output nodes. Go to label net option in the toolbar and label the output node as Vout. Place it here and the input node as Vin and place it here. Now let us perform transient analysis. Go to simulate. Go to edit simulation command. Then this edit simulation command dialog box appears. The first is a transient analysis. So let us go for it. Let the stop time be around 10 milliseconds because the input sinusoid time period is 1 millisecond and start time be 0 and step size be 0.1 millisecond. Press OK and paste here. Now let us run it. So let us plot input and output voltages. As you observe here, the green color depicts the input voltage and blue color depicts the output voltage. You can observe that there is a drop in voltage from input to output and there is a phase lag because some of the voltage get drops across the resistor, and due to the presence of capacitor there is a certain phase lag in the circuit. In order to calculate phase lag from transient analysis, what you do is go to this toolbar and select zoom the voltage values, and if you see this cursor points a place in this 2D axis and the values will be given at the bottom here, x and y values. If you place this cursor at the peak of the input waveform, you will observe that around 0.25 milliseconds this input waveform has its peak, and if you observe the peak of the output voltage, then you will find it around 0.338 milliseconds. If you calculate the difference between these two peaks, which is 0.338 milliseconds minus 0.25 milliseconds, it is around 88 microseconds. So in order to get phase difference, what you do is that divide this 88 microseconds difference by 1 millisecond, which is the time period of the input sinusoid, and multiply it by 360 degrees because the one complete cycle corresponds to a phase difference of 360 degrees. So this is how you calculate the phase difference between input and output using transient analysis, it will be observed for the circuit to be minus 31.68 degrees. You know that for a simple RC circuit, the transfer function is given by 1 plus j omega r 1 by 1 plus j omega rc, where omega is equals to 1 by rc is the cutoff frequency in radians. So if you come to the for the formula of phase, it will be minus tan inverse omega rc. So from that you can cross verify also. Now coming to magnitude, you can get it from the peak to peak voltages, which is input magnitude is around 4 volts peak to peak, and output is around 3.2 volts peak to peak. So now going to AC analysis, just use this scissor to cut the transient analysis, and then you can go to, before going to AC analysis, what you have to do is change this source, particular source. What you do is right click, then select none, and go for small signal analysis. Set the AC amplitude to be 1 and AC phase to be 0. Now click OK. Earlier, if you observe, this voltage source is sinusoid. Now it is AC10. So now what you do is you go to simulate, again edit simulation command, and go for AC analysis. Select the type of sweep to be octave or decade. The difference between octave is that the frequency axis increases in power of 2, and in decade the frequency axis increases in the power of 10. In linear it increases linearly. So select decade, click OK. Sorry. And number of points, let it be 100, and start frequency is 1 Hz because you cannot give 0 or negative frequencies as input, and stop frequency, let it be 5 kilohertz because for the circuit the cutoff frequency comes around at 1.59 kilohertz by using formula F is equals to 1 by 2 pi RC. So now let us run this. Let us delete this input. Now if you observe, this is the magnitude plot which is in the dark line, and this light line corresponds to phase plot. This is the magnitude axis in the left hand side, and in the right hand side is phase axis. Now in order to get the cursors, just go on this V out and click there, so these cursors appear. If you observe, this dialog box also appeared, and it is having contents like frequency, magnitude, phase and group delay, etc. So since here if you observe, the magnitude is selected, so the cursor scrolls on the magnitude plot. Now set the value around 3 dB. If you check here, select the magnitude around 3 dB. Place the cursor there. If you place the cursor, it can be observed that frequency is around 1.59 kilohertz. If you calculate the cutoff frequency, it turns to be about 1.59 kilohertz, and as you all know, we calculate cutoff frequency at minus 3 dB. So it is how you cross check the values, and you also know that at cutoff frequency the phase lag produced will be around minus 45 degrees. You can see here, and if you select this phase, now your cursors will scroll on the phase plot. This is how you perform the AC analysis in LT Spice. Hope you all understood. Thank you.